Hello everyone, welcome back to another video of An Average Programmer. Today we're going to solve problem number 5 of Leetcode, which is longest palindromic substring. And this marks as a medium problem, but I would say that it's an easy problem if you're able to find or to think how to find a palindromic substring from the normal way or the most popular way, because there is a problem. This is the problem 125 valid palindrome, in which we only check the first letter with the last letter, and if they are not the same, we stop our cycle. Well, we have a left pointer and a right pointer, and then we are checking all the edges of the word, and if they are not the same letter, then we stop our cycle and we return false. And if we're able to get through the whole word and we get into the intersection of the left pointer with our right pointer, then it's going to be considered as true. And that is the most popular way to find a palindrome. But we need to be thinking outside the box. How can we identify a palindrome without doing that? Okay, so let's see the first example. In this case, we have two options. The first one is that we can return BAB or ABA. Why this? Because if we see this is a palindrome, and there is also another palindrome which is ABA, and they are both of length 3. So we can return either BAB or ABA. Okay, so that is good. Let's notice that this is an odd length palindrome, but there could be also some even length palindromes. For example, in the example number 2, we can say that we have this palindrome because the first letter, let's say that we have this substring BB, and the first letter is B and the last letter is B, so that is also considered as a palindrome. And that is the only, well, yeah, that is the only palindrome that we have in our string. So we can have either even length palindromes or odd length palindromes. Okay, so that is good. And I think that we should be watching how can we identify a palindrome from the normal way, because we will have to be checking all the substrings, and also we are going to be iterating through the substring with 2 pointers, the left and the right pointer, but that is going to be costing us a lot of time complexity. So there is an easier way to do this. We can go either from the outside to the inside or from the inside to the outside. Okay, and you could say that this is going to be the same time complexity, but it is not, because because we are looking for the longest palindromic substring. We are not watching we do not care if it is a palindrome or not. Well, we obviously care about that, but in this case we need to find the longest one. So we only need to check the different lengths of all the palindromic substrings. So a good way to do this is from the inside to the outside. Okay, so I hope this was clear for you, and I'm going to be writing the code for this. So we will have to iterate through all the letters, obviously, and we will need to expand from the center to the outside in each index. Okay, and we are going to see very easily if they are not palindromic substrings, because if they are not the same letters, then we can just jump to the next letter. Okay, so I think with the code it's going to be easier for you. So we will have the result variable, which is going to be called longest palindrome, which is going to be of type string, and it's going to be an empty string. Okay, so there's going to be a mutable variable, because this longest palindrome can be different in each iteration. So I'm going to be returning this to not forget to return the string. And we will have to iterate through all the letters. Okay, so for doing this, I'm going to use a normal loop, and I'm going to start in the 0 index. And I'm going to repeat this while I is less than the length of s. And I'm going to increment I in each iteration. Okay, so there are two possible longest palindromes, two types of possible longest palindromes. The first one is going to be the odd length palindrome, and the other one is going to be the even length palindrome. Okay, so we will need to have obviously our two left and right pointers, but they are going to start at the same position of the eye. Okay, why it is? Because we want to start from the inside to the outside, meaning that every time that we are moving our pointer in the scanning of the word, we are going to have our left and right pointers at the middle. Okay, so hope that was clear for you. And I'm going to say that this is going to be to equals I, and right is going to be equals to I plus 1, because we're going to have odd length palindromes. So this is considering that the largest palindrome is of odd length. Okay, so that is good. And let's just identify the following. We will be using a while loop to see if we are in bounds, if our left and right pointers are in bounds. So I'm going to check first if left is bigger than 0 and right is less than s dot length is s dot length, and we're going to be checking if they are the same, then that is considered as a palindromic substring. So if s in the position of left and s in the position of right are the same, then this means that we can consider this as a palindromic substring. And we just need to see, is the new length bigger than the length of our longest palindrome? If that is the case, then we can update our longest palindrome. Okay, so if left plus right plus 1 is bigger than the longest palindrome dot length, then that means that we have found a new longest palindrome, and we can update our longest palindrome. So our longest palindrome is going to be equals to the substring of left and right. Why this? Because in the substring function we need to this is considered as inclusive, but the right boundary is not considered as inclusive. So we need to add 1 to our right pointer. Okay, so I hope that was clear. And we just need to decrease the value of left and increase the value of right. So it's going to be left minus minus and right plus plus. So that is good. And that is going to be the same for our even length palindromes. So I'm just going to copy and paste this. And we don't want to redeclare left and right. And in this case, we're not going to start from right in I plus 1, because this is an even length palindrome. So, oh, sorry, I got it inversed, sorry. Uh-oh. Okay, so I think that this should be good. I'm going to run the code to see if this is working or not. Okay, so let me see what I'm doing wrong in here. So while left is bigger than equals than 0 and right is less than sorry, if right plus 1 minus left is bigger than longest palindromic length, then that is going to be considered as a palindromic. Sorry, I made a mistake. So this is accepted. Okay, so let me submit this. I think this should be good. Okay, so this is passing, and the time complexity of this is n squared, because in the worst case we would be checking we will be to be expanding each letter of the main word. So that is why it is a quadratic time complexity. Okay, so I'm going to leave the code in the comment section of the right solution. So hope this was useful for you, and see you in another video. Bye.